In lecture number 28, we will continue the discussion of the topic functions, which are essentially a block of code with a name. Before watching this lecture, I would suggest that you watch live lecture number 8, which was conducted last Tuesday. So let's continue the discussion of functions here. This code takes two numbers such as 68 and 78, and it computes the greatest common divisor of these two numbers. Let's say we have two numbers 11 and 55. So the greatest common divisor which can both divide 11 and 55 is obviously 11. So before I'm not going to explain how this code works. We are going to take this code as an example and see the utility or see the benefit of using functions. Let's say this code takes two numbers 68 and 78, and it runs some code and it computes the greatest common divisor or GCD of 68 and 78. So first we are going to run this code, and after running this code, it says that the greatest common divisor of 78 and 68 is 2. Now let's say after this all code is defined in the main function. This is also a function, and a function has a name, and the most telltale sign of a function are the round brackets. So whenever we see round brackets next to some name, such as here, which is the main function, we are talking functions. And the the main function has a code body spanning from this curly bracket to this curly bracket. Now what we are going to do is, let's say as an example, we are going to do some work here, some other code with just something, and then we now want to compute the GCD of 11 and 55. Now what I mean, before we know functions, what we would have done is that we would have taken this, because we have already declared these variables, so we did not need to declare them again, obviously. So we are going to take this code, we are going to copy it, from this point. So we have this code again, and we are going to say m equals to 11 and n equals to 55. So we run this code again, and it says that the greatest common divisor of that's before 78 and 68 is 2, and the GCD of 55 and 11 is 11. Now let's say after running this code, we do something else here. Any code, any cout statements or something else, and for some reason we want to compute the GCD of, for example, 77 and for example, let's say a number, for example 26. So what we are going to do is that we take this code and we copy it again here, and we say that we want to m equals to 77 and n equals to 26. So if we run this code again, it says that the GCD of 77 and 26 is obviously 1, because they are not divisors of each other. So I'm not going to explain how this code works, but you get the idea that if we want to recompute the whole thing, we need to copy paste the whole code. So you can see that our main function, our main program is now quite long. So whenever I want to compute the GCD of two numbers, I need to copy paste the whole code and change the values. Now there is a simpler way of doing that. Instead of copy pasting the whole code again and again, what we can do is that we can make a function. Let's make a function here. So I'm going to not going to run this program. What I can do is I'm going to delete these things. So I'm going to delete whatever code I have written here, and I'm going to run this code just to make sure it runs okay. Yeah, it runs okay. So what I'm going to do is that I'm going to take this code, this whole code control, I'm going to copy it, I'm going to make a new file, and obviously and I'm going to enclose it. Obviously I need to include IO stream, because I'm using the cout string modifier, as well as I'm using the standard, using name space standard. And now I'm going to enclose this whole code which computes the GCD of two numbers in a function body. So I'm going to write the name of the function. First I need to define the return type. This function doesn't return anything, it just prints whatever it's printing. It's not returning wherever the function is called. So I'm going to call it, and I'm then going to name this function GCD, and let's hope that GCD is not the reserved keyword. I don't know about it, so if it gives an error, so I'm going to rename it something else. So I'm going to say that this function takes the two numbers as parameters or arguments, integer m and integer n. Since I've already defined them, this curly bracket goes down here, and since I've already declared them in the function header, this is a function header. This first line is a function header. So I'm not going to declare these variables again, because obviously these m and n are defined here. Since the values of m and n are going to be passed whenever the function is called, so I do not need those as well. So I have declared I have deleted m equals to 68 and n equals to 78. And then I'm going to save this file. So let's Control S, and I'm going to save this file as gcd function.cpp, or you can just name it as gcd, so no problem at all, gcd.cpp. Okay, so I'm going to compile this code, so there are no errors, hopefully. Now what I'm going to do is I'm going to go back to this code. Since I have made a function GCD this here, so what I can do is I can include the gcd.cpp, and make sure that whatever you have written as your own function, or maybe multiple functions, those CPP files are going to be included within two double quotes, not the less than and greater than sign, because they are reserved for the standard C++ libraries. We are going to use the double quotes. Okay, so next thing we need to do is that one more thing. If I save this thing, this GCD file is within the same folder. The folder name is lectures 28, 29, 30, because I'm going to include all the CPP files in this folder. So if this GCD file would have been in some other folder, maybe D drive or some other hard disk partition, and some other folder, let's say that the other folder is d:// computer science programming / and so on and so forth, then you would have to write the whole path here. I mean, let's say if it were in some other folder, I would have included this thing in computers and programming and so on and so forth. Let's say that's the name of the folder, and in there this GCD file is there, so I would have included the whole path. But since this gcd.cpp file which I've just made is in the same folder in which this gcd example.cpp, this whole file is there, so I do not need to write the whole path, because it's implicitly understood that I mean, if you are including it without giving the whole path, obviously that's in the same folder. So this whole code is in the gcd.cpp, so I do not need to write it, obviously. And the main function looks like this. So I mean, return 0 is obviously there. I mean, if you do not even write return 0, it's not important, because that compiler just included for us. So I mean, that's not significant right now. But let's say I want to compute the GCD of two numbers. Let's say the first number is 78 and the number is 68. So what this thing would do is going to pass the values of 78 and 68 to this function. So 78 is going to be assigned to m, and 68 is going to be assigned to n, and then it's going to compute the GCD of these two numbers, and then it's going to print whatever the GCD of these two numbers are. So let's say I compute this, and it's going, since it's not going to return any value, it's void means it's not returning anything, some value. I mean, had it been returning anything of some type, I'm going to include that, but obviously not here. So it's just printing some statement. That's it. So wherever this function is called, it's not returning any value. I'm going to explain what we mean by returning the values in another example in this lecture. Okay, so let's say we compute this and then we do some other work here, maybe some printing some statements, or maybe doing anything else. Okay, then the next thing, let's say we want to recompute the GCD of 11 and 55. So we are going to call this function again, which is defined in this CPP file, and now this whole function body is going to be called up again, and the value of m is going to be assigned the value of 11, and this variable n would have the value of 55. Okay, so and then n is going to print the GCD of these two numbers, and let's say we do some work here, some unrelated work to this, and then we, for some reason, we want to recompute the GCD of let's say I think we did 70 and 90. Let's say we do the GCD of some number, let's say 60 and let's say, for example, 10, or it's going to be 10 obviously. So let's pick a number, for example 720. Okay, so the greatest common divisor of this thing. So we are calling the function, remember what I said, that whenever we are seeing the round brackets, with a name attached to them, it means that we are calling a function. That's the biggest sign that we are calling a function. Whenever you are seeing some square brackets, this is a sign of a data structure known as array. And whenever we are seeing the curly brackets, we are enclosing some code block obviously, so they essentially mean the code block which of some loop, maybe of some function, these pretty much the two things. So if you can see that instead of writing that code again and again, our code with now using the function which does that thing for us, and we have included that file only once, so we do not need to write the code again and again. Our main function becomes really compact. So first run this thing before learning how it works. And here it is, that GCD of 78 68 is 2, GCD of 55 and 11 is 11, and GCD of 720 and 60 is 60. So before, I'm not going to explain how this GCD code works, but it's really simple. If you can just write this code in your copy and try to understand how this works, and make 4 blocks, 4 square shapes in your copy, and name them as temp, m, n, and r. And then you would understand how this works, because this thing is going to run, within the loop. But that's not the topic here. The topic here is function. Our code becomes really simple to read, and when whoever is reading this code is going to understand, look, these two numbers have their GCD computed by calling this function. Then usually whenever we are writing large programs, those large programs have multiple functions, they have multiple tasks to do. So what we do is, instead of writing the whole code in the main function, we approach it in the modular fashion, or in the subroutine fashion. Let's say we want to do something, we name that something as a function, and one programmer writes that function, and another programmer writes another function, and another programmer writes another function. So whoever is writing the main function is going to include those CPP files which other programmers have written, and then he or she, whoever is writing the main function, is going to just call the function with the appropriate values. Maybe the values are, let's say, if I write cin, or maybe first write cout, and I'm going to say enter 2 numbers, just like that. So enter 2 numbers, and maybe write \n, and then we just write semicolon. Okay, so cin, and we take those numbers to some variable, let's say x and y, I mean, I could have used m and n because these m and n are the local variables of this file. So these m and n simply do not exist in this main function. So I could have used m and n here, no problem with that. That's just to avoid confusion. But I haven't declared them yet, so I'm going to declare them. I'm going to declare them integer x comma y. So I'm going to take, and then I'm going to compute the GCD of this x comma y. So if I run this code, it says enter two numbers. So if I press for example 22 and 33, sorry, it's due to antivirus, enter two numbers. So if I press for example 22 and 33, it says that GCD of 33 and 22 is 11. So I mean, I could have done that using the main function. So this code becomes much more simple to read. It's actually much more maintainable. I mean, there are lesser bugs to because whenever you are copy pasting the code, you have no idea. I mean, very few people will have idea what that code does. And if you are using this code written by some other programmer, I'm using the code written by some other programmer, and I've named that code as GCD, or that programmer has named it as GCD. So I'm just using that CPP file and using the function contained therein. It is also possible to improve the code. Let's say the programmer says, look, I have found a new way or new algorithm to compute the GCD of these two numbers. So that programmer would have just changed the code, saved it, and sent that file to whoever is writing the main function. So that person is going to include the CPP file without even knowing or without even caring to know what that CPP file has done or what changes are there. But that programmer, whoever is writing this main function, is going to just use that file or use that function to do the required task. And really, the programmer of writing the main function doesn't even need to know how that GCD code is implemented. He or she is just concerned that okay, as long as we have a name of the function and what values it takes as arguments in the round brackets, and whether it returns any value which we need to save, or it's not even necessary to save the return value actually. So this thing is going to this line is just going to run this function. In this example, I've used the code from lecture number 24, in which I developed the code for the calculator using the switch case conditional statements. But here, instead of performing the operations in the cout statement, we are using the functions to perform the required operation. Just to understand the prototype function and function prototype, as well as how to define the functions in the same code, as well as the return type. So here I have included the IO stream using namespace standard, and this is our main function. But the difference here is that I have now declared 1 2 3 4 5 6 function prototypes before the main function, and I'm saying to the compiler that I'm going to call these functions with these names along with the values whatever it is expecting, and the definitions of these functions are given after the main function. So let's take a look that how these functions actually work. This is the main function. Main function is not expecting any value, but it's actually returning an integer, which is after successful completion we say return 0. Now coming back to the sum function, I mean, it's a simple code. We really don't need to use the function, but just to understand how functions actually return the values. So I have declared the function prototype. The name of the function is sum, and it's expecting two integers as arguments, and wherever this function is called, it's going to return an integer. So here let's take a look at this code that I have declared two variables xy and a character operator, and I'm going to ask the operator first. There's a slight change as compared to lecture number 24 code. Here I'm going to ask the operator first because one of the operator is going to be the exclamation mark or the factorial, and for that it's going to ask a single number and compute the factorial.
So that's why I have asked the operator first, and then I've asked the whether the user wants to enter two integers or one single number. So I've taken the input from the user, and then I've run the switch statement and saying that if this OP, which is the character entered by the user, if this OP is equals to plus, then I'm going to ask enter two integers and assign those integers to x and y. And then I call the function sum xy. So this function, this is just a prototype, and this prototype is defined here, and the definition, the prototype has the semicolon. This is important. You do not need to write the names of the arguments of this variable, just need to declare the types. So if I go down where I have declared defined the function, so here I need to write the name of the argument in which the values are going to be mapped, and I've written integer sum, integer a, integer b. That means that whenever this function is called, I'm going to pass two values, and it's going to return a value, and return the value wherever this function is called, and the return type is an integer. So coming back to here this thing, wherever this function is called, it's going to return the value of x plus y, or this x and y are going to be mapped to the local variables a and b, and this a plus b is going to be returned wherever this function is called. So x plus y is going to be returned here, x is going to be mapped to a, and y is going to be mapped to b, and it's going to return whatever the, wherever this function is called is going to return, it's going to return the value x plus y or a plus b, and then I'm going to break this switch statement. And if the user enters the minus, then I'm going to again ask two integers, because if this thing is not true, then this thing could have been true, and take the inputs, and then I call the difference function. The difference function, the prototype is given in the beginning. This is not the definition of the function. I'm just saying to the compiler that this function is defined below the main function. So if we go down, this main function, this difference function expects two arguments and returns say minus b, and if the user typed in the multiply, then this mult function is going to be called, and it's going to return a into b. So the return type is long. The reason is that multiplications of integers will result in larger values, so that's why I have declared the return type as long integer. So it's a 8-byte number, could have been an 8-byte number. Then the division operator, I've called the division function, divx. This is my own defined function, and it's expecting the values a and b. Then I have typecasted it to double type variables. I could have written double a's. If I have written something like double a divided by b, that would have still returned the integer. The reason is that a is an integer and b is also an integer, and that would, the result of these two integers division would have been an integer. Even if I converted it to double, that would have still given me the integer answer. So for that I need to convert at least one of these arguments, a or b, or maybe both, to double. So no need to write this line, and then I return that, because let's say if I divide 2 divided by 3, the answer should be 0.6667. And lastly, if the input operator is a percentage, which is the remainder operator, so I've defined a function remainder, and that remainder operator is a percentage b, so that's also an integer if there is a remainder. And lastly, if the user enters the exclamation mark, then I do not need to ask for two integers, I ask for a single integer, and then I computed the factorial of this number. So you know that factorial is it expects a number, the argument, and it returns a very large number possibly, and it returns let's say 5 factorial is 5 into 4 into 3 into 2 into 1. So obviously we have to run some kind of a decrementing loop. So if the user enters 0, so 0 factorial is 1, and I did not take that into account, so I should have written if a equals to 0, then I should have written return 1, something like that. so I did not write that before, so you need to write that. Then I declared the answer for the factorial as 1. Then while a is greater than 1, f equals to f into a minus minus. So the first would be f equals to, let's say if the user enters 5, so the loop will run, and in the first iteration the value of f would have been 5 into 1, that would be 5. Then it would be into 4, into 3, into 2, into 1. We do not need to multiply it by 1 actually, so we just exit it at 2. Then we return f, which is the wherever this function is called is going to return the factorial. So this factorial, I mean, we're calling this function here, and if we run this code, it says enter an operator. Let's say if I type this operator, it says enter a number, enter integer. If I press 10, the 10 factorial is this number. Now if I run this code again, if I write the division, if I write 2 and the 2 numbers, then this is the division division operation. And if I press simple plus, it says enter 2 numbers. If I write 5 and 7, so 5 plus 7 is going to be 12. So this is an example of using functions to make a simple calculator. And the new thing which we learned in this example is that these functions are actually returning some values, and we are using those values to display the result. And the values, we return those values using the return statement. We could have multiple return statements if some condition is true or if some condition is not true.